Welcome back everyone. Have you ever tried to carry a heavily loaded tray with one hand? If you grab it too far to left, it tips and crashes, and too far to right, same disaster. If you have to find exact perfect center of gravity where the weight of left exactly equal to the weight of right, so it balances completely, in competitive programming we have to extract same problem. Today we are tackling find the middle index in array. We need to find the perfect middle pivot point of the array where sum of numbers on the left matches with the right. We are going to solve it, but more importantly, we are going to master the pattern behind it called prefix sum. So let's balance the scale. So here's the problem. If you see this example, it is returning output as 3. Let's see the explanation. So the sum of number before 3, which is 2 here, or we can say 2 plus 3 minus 1 is 4, and the sum of the number index 3, like after index 3, is 4. So this third index is the pivot element to balance the weight. So we just have to return this index value. The most intuitive way is brute force way. It simply tests every single index. We point at index 0, run a loop to add everything to the left, then run another loop to add everything to the right and do the match. If not match, we can move the index to 1 point further and do the exact same thing again. So let's see that in action. I have taken the same example of this one. Now iterating through the given array using for loop, we can initiate two variables called left sum and right sum. We can calculate the sum of the element to the left as we discussed using this inner for loop, and we can keep saving that in left sum. We can again calculate the right sum of the current index and save it in right sum, and we can check if it is equal. We can return that index. That is the whole requirement. And if the middle element not found, we can just return -1. So let's run this. We need 3. Let's see. So yeah, it is giving me the solution, but let's try to optimize this. So for optimizing this, we can take a total sum and you can simply apply a simple math. Let's see how. I've just calculated total sum using this for loop. You can apply this formula if total sum is equals to the left sum plus the current element and plus the right sum. And I don't have to tell you that if you want to calculate the right sum, you just have to subtract total sum from left sum and the current number. So that is our final formula. And we can take a variable of left sum initially as 0. We can initiate a for loop to iterate over each element, and we can check for right sum if it is equal to left sum or not. For that, we are just calculating the right sum using the same formula as we discussed. We check the equality. If it is equal, we will return that time only, because we need a single index element. And if that is not the case, we just increment the left sum to the current number. So in this way, we just get rid of that extra for loop that we have discussed, right? And if our for loop story does not able to find the solution, that means solution does not exist and we will return -1. Straightforward, right? So let's just run this. So yeah, it is also giving us 3. Now let's try to paste in Leetcode. So here is our Leetcode. Just pasting that thing. Try to run simple test cases. All are passing. Try to submit this, and boom, we beaten the 100% of the programmers. And that's the prefix sum pattern in action. Once you see it, you can't unsee it. And it suddenly makes dozens of competitive programming and FAANG interview questions look incredibly easy. If this helps you crack the logic, hit the like button and subscribe to keep building your pattern recognition. See you in the next tutorial. Keep coding.